Hi everyone. In today's lesson, we're going to talk more about motion. So same problem as yesterday. We have a particle that's moving across a horizontal line according to this velocity function. But now I'm going to ask you more questions about it. So first thing says, find the instantaneous acceleration at 3 seconds. So acceleration, we should remember from motion part 1, is that that's the derivative of this velocity function. So let's first find it. So when you take the derivative, you do 3 times 2, which gives you 6, and decrease the power by 1. The derivative of negative 48t is just negative 48, and then the derivative of a constant is 0. So if I want to find the instantaneous, meaning if I want to find the exact acceleration at 3 seconds, all I have to do is plug 3 into my acceleration function. So 6 times 3 minus 48. So take a second, plug that into your calculator, and then hit resume when you're ready for the answer. All right, so you should have gotten negative 30. So the acceleration at 3 seconds is negative 30. Perfect. Okay, next, find the instantaneous velocity this time at 10 seconds. So we already have the velocity function, right? We have the velocity function from the original is 3t squared minus 48t plus 144. So that's at 10 seconds. So all I'm going to do now is plug in 10. So 3 times 10 squared minus 48 times 10 plus 144. So go ahead, pause the video, type that into your calculator, and then hit resume when you're ready for the answer. Okay, so you should have gotten negative 36. So my instantaneous velocity, v of 10 at 10 seconds, is negative 36. Okay, part C says, find the intervals of time where the particle is speeding up and slowing down. So speeding up and slowing down requires us to compare our v of t and a of t number lines. So we first, step 1, have to set v of t equal to 0, which we did in yesterday's video, so I'm just going to kind of copy it over. So my v of t function is 3t squared minus 48t plus 144. When we set that equal to 0 yesterday, we took out a GCF of 3, and then we factored, and we got 12 and 4, and those were our solutions, 12 and then 4. And we made a number line with those values, right? We included 0 because time can never be negative, and we had 4 and we had 12. And it was plus, minus, plus. So if you'd like to just copy that down so you have it, that's what we did yesterday. So now in order to figure out if I'm speeding up and slowing down, I need to take my acceleration function and set that equal to 0. So we just calculated that my acceleration is 6t minus 48. So if we set that equal to 0, we get 6t minus 48. We can add 48 to both sides. And we get that 48 is equal to 6t, and divide both sides by 6, and we get that t is equal to 8. So we need to make a number line for this, right? We can call this our a of t number line. Sorry, I didn't label this one. We can call that my v of t. So again, we should put 0 because time can never be negative, and we can put 8 somewhere on here. So we're going to go take our a of t function this time, and we're going to put this into our y equals in our calculators. And we're going to test a value that's less than or between 0 and 8, and then a number that's greater than 8. So take a minute, pause the video, do that, and see if you get pluses and minuses. All right, so on the left side, if you plugged in, say, 5, right, you should be getting a negative value. And then on the right side, if you plugged in, like, say, 9 or 10, you should be getting a positive value. So this doesn't necessarily tell us where we're speeding up and slowing down. That's what step 3 is for. We must compare these two number lines. So it's a little easier for me if I had them on top of each other. So I'm just going to rewrite them. So I have v of t, 0, 4, and 12. I have pluses, minus, and pluses. And then on beneath it, we're going to put my a of t number line. And the most important part here is that we keep them lined up. So where this 8 is needs to go in correspondence to where these numbers are. So the 8 should go in the middle of them, not necessarily anywhere else. And we're going to copy down our minuses and our pluses. So remember, we speed up when the signs are the same, and we slow down when the signs are opposite. So I'm just going to draw in some lines here so we can clearly see what's happening. So we're looking for where the signs are the same. So I see the signs are the same here and here, and here and here. So the same signs is where I'm going to speed up. So I can even write same signs. So we have from 4 to 8 and 12 to infinity. So we can just write that, 4 to 8 and 12 to infinity. And now I'm looking for where it's going to slow down. Slowing down is where the signs will be different. So the signs are different here and they're different here. So we can say that we will slow down when the signs are different. Different or opposite. So we have from 0 to 4 and then from 8 to 12. So 0 to 4, union 8 to 12. All right, so that's it. Those are my answers for speed up and slow down. And then the last thing is if I ask for a specific speed, find the particle's speed at exactly, I'm just going to change this instead of 15 seconds, I'm going to change it to say 5 seconds. So find the particle's speed at 5 seconds. So we have to remember that speed is defined as the absolute value of the velocity function. So if we know this definition, we know that we need to find the absolute value of the velocity function at time equals 5 because they want to know at exactly 5 seconds. So take a minute and find your v of t function and put that into your y equals and calculate v of 5. If you need to do it by hand, you can just do it on the side here. V of t is 3t squared minus 48t plus 144. And you're just going to plug in 5. You can use the calculator for the y equals, like I said, or you can just simply plug in like I'm doing here by hand. Either way, take a minute, try it, and then hit resume when you're ready for the answer. All right, so you should be getting negative 21. So I need to take the absolute value of that, so my particle's speed at 5 seconds will be 21. All right, that's it for today. If you guys have any questions, now's a good time to jot them down. Otherwise, I'll see you in class tomorrow. Have a good night.